Okay, so this time we are going to show you how to use MATLAB to write a demonstration code to show the RMS values. So first of all, you do clear all, close all. So clear all will close all the variables existing there. For example, if I already have some stuff in my workspace, what can I do? I just clear all. And then you can see that all these stuff in the workspace, all these variables will be closed. So close all, basically close all the figures. Suppose I have a figure right now there. And then if I use close, it will just close it. So in general, I will use these CLC. You put here, you just clear all this command window. So it's a good practice to put them there. And then what I can do is I'm going to define, as I have done before, I'm going to have, I'm copying this so I don't have to do that again. I have frequency, I have omega equals to 2 pi times frequency, so that's my omega, and then I have an initial angle. And then I'm going to say, hey, I have these two lines here. So this shows I wanted the RMS value to be 120. So as a result, the magnitude of the voltage will be my RMS value times square root of 2. And then I'm going to select the time for that. So when I'm going to the time, you can see that here is something I want to show you. You can select a very large time step, say for example 0.1 second. And then see if it'll work. Let me just plot these out. Again, those are just the things that we learned before. We plot time will be my x-axis, voltage will be my y-axis, and then I want to plot them out as red. And then the line width will be 2. And then I put a label there. My x label will be time, y label will be voltage. And then the title will be maximum voltage versus RMS voltage. And then I'll hold it on so I can plot some other figures. I put a grid on so I can see the grids. So let me just say demonstration new. So you can see that when I plot them out, they have the grid there because I actually need to do See, the reason I have not anything shown up here is because I select this step size to be 0.1. Suppose I make it 0.01. You can see it's like that. This is because, let's say, 1 over 60 is 0.001 second, around that. So if I like my step size to be larger than that, that means I go from 0 with a step size of 0.1, then that's already out of my range. So I need to select the step size really small. So if I do 0.01, you can see that I only have 1, 2, 3, 4, 5 points within the range. And then obviously that doesn't look like a sine wave, okay? So let me just put down there another, make it a finer. You can see that you can still see some jumps here, but now it's look like a sine wave. So if you want it to be really fine scale, you can just make it even smoother. See, this smooths out all these bumps. So this is how you will select these time steps. Okay, so in general, you need to know what is one cycle, the length of it will be. Suppose you have a 60 hertz, you will see that one length of the cycle is about 16 millisecond. So your time step will be at least, say you have 16 points in between, then that will make it this divided by 16. So you should have a step size at least 1 millisecond. So usually if you go more than that, that means that you have 160 points or maybe 100, then you should be good. So that's why I would suggest you to go with either 0.0001 or 0.01. Either way will do. See, you can get a smooth sine wave that way. And then the other thing that I want you to take a look at is actually the RMS value. So when you want to plot out the RMS value, then what you do is you see that you have the line, and then you have this X. This is basically your X. One value will be 0, Y1 will be the RMS value, and then you go the maximum here, the time, the maximum time, and you go voltage RMS value. So what this will do is this will plot out basically the RMS value. So you identify this point, and then that point you draw a line in between, that will be this command. So if you identify the minus the voltage RMS value, this will be 0, this coordinate will be 0, and the minus this voltage RMS value. So this is x1, this is y1. And then this is your x2, which is the maximum of the time value, which is right here. And then the minus RMS value, so that's this point. So if you draw a line between, then you have your RMS value that way. This is how you would plot out your RMS value.